Okay, here's what we actually know about human history, and it's kind of uncomfortable. We were never alone on this planet. Not even close. Right now, there's one human species on Earth. That's us, Homo sapiens, the only ones left. But rewind 300,000 years, which evolutionarily speaking is basically yesterday, and you'd find at least 9 different human species walking around, possibly more. Some smarter than us, some tougher, some older by millions of years. We didn't evolve in isolation, but in this messy, competitive, interbreeding crowd. Which raises a pretty uncomfortable question. Why are we the only ones still here? Number 7. Australopithecus, the first biped. Upright on 2 legs, hands completely free for the first time. That's what Lucy proved was possible 3.2 million years ago. Donald Johanson finds her on November 24, 1974, in the Afar region of Ethiopia, 40% of a skeleton, and they name her after the Beatles song playing at camp that night. What's strange about Lucy is that her brain was about the size of a chimpanzee's. Long arms, curved fingers, built for climbing trees, yet her pelvis and knee joints were unmistakably built for walking upright. She was somewhere between ape and human, an in-between that shouldn't really work, and yet it did, for millions of years. Lucy walked upright 3 million years before we even showed up. Why bipedalism evolved in the first place is still debated. Freeing up hands for tool use and carrying food is the dominant theory, though it's honestly not the only one. We're still working that question out, which makes it more interesting if anything. Number 6. Homo habilis, the toolmaker. The first time a hominin deliberately shaped a tool was roughly 2.4 million years ago in East Africa. The species responsible was Homo habilis, meaning handyman, a name Louis Leakey gave them back in the 60s. Their brains were about 600 cubic centimeters, roughly halfway between a chimpanzee and a modern human. But what matters is what they did with it. They made tools, not just picked up a rock and used it, but shaped stone into specific forms. They called it Oldowan technology, and what it involved was deliberately shaped flakes and choppers, made using techniques consistent enough to teach to someone else. That teaching part is the real cognitive leap, because it means holding an abstract procedure in your mind and transmitting it to another person. Most animals never get there. Teaching a technique, passing it on, building on what the last person figured out. That loop started here, 2.4 million years ago, and we've been at it so long that most people don't fully register what that number actually means. Number 5. Homo erectus, the marathon survivor. If there's one thing that separates Homo erectus from nearly every other species on this list, it's sheer staying power. First discovered in Java by Eugene Dubois in 1891, and later in China, the one they called Peking Man, by Davidson Black in 1929. They were around from 1.9 million years ago to roughly 110,000 years ago. That's almost 2 million years of continuous existence. I mean, sit with that number for a second. Modern Homo sapiens have been around for about 300,000, so Homo erectus outlasted us 6 times over, and we're not even done yet. They were the first to control fire. Evidence from Wonderwork Cave in South Africa puts that at around 1 million years ago. First to leave Africa, the first intercontinental human species, spreading across Africa, Asia, and Indonesia, and adapting to completely different climates along the way. The most successful human species in history, it wasn't us. Which, if you stop and think about it, is maybe a little humbling. Number 4. Neanderthals, the misunderstood genius. We need to clear something up right away. Neanderthals weren't stupid, and that stereotype is about 50 years out of date. Their brains were actually larger than ours, roughly 1,500 cubic centimeters compared to our 1,400. They lived in Europe and Western Asia from around 400,000 to 40,000 years ago. Excavations at Shanidar Cave in Iraq back in the 50s showed evidence of care for injured individuals over extended periods. They buried their dead and made art. Cave paintings in Spain have been dated to at least 65,000 years ago, which puts them 20,000 years before Homo sapiens even arrived in Europe. That dating's still contested in some quarters, though the methodology is solid. Reward: Svante Pääbo sequenced the Neanderthal genome in 2010, work that eventually won him the Nobel Prize. If you've got European or Asian ancestry, roughly 1 to 2% of your DNA is Neanderthal. They didn't go extinct in the way you'd picture it. They merged with us. So the next time someone uses Neanderthal as an insult, they're basically describing themselves too. Number 3. Denisovans, the ghost species. Most species, when they disappear, at least leave something behind. A bone, an artifact, a footprint pressed into old sediment. Denisovans left almost none of that. They're a human species we know existed, but have never actually seen. Pääbo's team finds the evidence in Denisova Cave, Siberia, in 2010. What do we have? 3 teeth and 1 finger bone, reduced to 4 objects in a collection drawer somewhere in Leipzig. No full skeleton, no reconstructed face, just DNA. But that DNA keeps showing up. Modern populations like Melanesians, Aboriginal Australians, and Tibetans carry anywhere from 1 to 6% Denisovan DNA. And the really wild part is that Tibetans carry a variant of a gene called EPAS1 that allows them to function at altitudes above 4,500 meters, conditions that'd be debilitating for most people. They got that gene from Denisovans, a species we've never laid eyes on, but which gave modern humans the ability to live on the roof of the world. They're genetic ghosts, basically, and they're still shaping who we are today. Number 2. Homo floresiensis, the Hobbit. The Hobbit comparison wasn't coined as a compliment, but it stuck. And honestly, it fits. On the Indonesian island of Flores in 2004, a team led by Peter Brown announced a discovery that nobody was expecting: an adult human species standing about 3.5 feet tall, with a brain the size of a chimpanzee's. And yet they made stone tools, hunted stegodon, a pygmy elephant, controlled fire, and survived on that island until at least 60,000 years ago. How they got there in the first place is still an open question. The sea crossing would have required something, whether rafts or lower sea levels creating a shorter route, though the evidence for boats specifically is thin. Island dwarfism, the evolutionary size reduction you see in isolated populations, is well documented in animals like deer, elephants, hippos. In humans, nobody saw this coming. A human species the size of a child, with a brain 1/3 the size of ours, that hunted and made fire for tens of thousands of years. Whatever we think we know about the relationship between brain size and intelligence, Floresiensis complicates it considerably. Number 1. Homo naledi, the paradox. Homo naledi shouldn't make sense, and that's basically the whole story. The site was Rising Star Cave in South Africa, where the fossils turned up in 2013 and were announced to the world in 2015. Lee Berger and his team at the University of the Witwatersrand made a find that's been causing arguments ever since. A brain of roughly 500 cubic centimeters, which is about 1/3 of ours, anatomically primitive, a strange mix of features that look ancient alongside features that look almost modern. And yet the evidence from the cave suggests they deliberately placed their dead deep inside nearly inaccessible chambers, not carried there by water or dragged in by predators, but placed there, intentionally, repeatedly. Whether that counts as burial in the full ritual sense is still being debated, and, well, not everyone in the field is persuaded, honestly, but the pattern's hard to explain otherwise. Deliberate burial, if that's what it is, requires abstract thought, a concept of death, maybe some notion of what comes after. The kind of cognition we've always associated with large modern brains. Homo naledi's brain was 1/3 of ours. If the interpretation holds, it forces a genuine rethink of how we connect brain size to inner life. And that brings us to the question this whole list has been building toward. If a species with a brain that small was capable of something like that, why is it gone? Why are any of them gone? Why is it just us? The honest answer is, nobody knows for certain. Climate dismantled habitats and took specialized species with it. Competition pushed slower adapters out, and interbreeding complicates the picture entirely. Neanderthal and Denisovan DNA didn't disappear, it's in us, which makes their end less like extinction and more like absorption. But there's one possibility that tends to get discussed quietly, if at all. Skeletal evidence from several sites shows trauma patterns consistent with interpersonal violence. Chris Stringer at the Natural History Museum in London has written on this. The evidence is circumstantial, incomplete, and accumulating. The possibility that we didn't just outlast the others, but in some cases actively drove them out, is one the field doesn't love sitting with. At the end, we are not the best, not the smartest, just the last ones standing.